Hi, this is Ed from Wright. I hope you're doing well today. Today we're going to talk about mower design principles. Some of these things that I've learned over the years are really important when we focus on how we make our mowers, what are our priorities, and I put some of these things in writing just to give you a little bit of window into how we think when we were designing these machines. So first off, the number one thing is that our equipment has to be highly productive. Our mission in life is to make commercial mowers for folks like you that are running a business using these mowers. Labor is your number one cost. Because labor is your number one cost, it's a priority to us that these machines are highly productive. You can cut fast with them. They have a lot of power, very maneuverable, and these kinds of things. And if our machines are not more productive than something else in the market, you may as well buy somebody else's mower. And so, our business is based on doing this thing well. That's why we have a focus on stand-on mowers and an expertise in that type of thing, in the center of gravity of machines. These types of concepts is our focus. We actually have another video that's specifically about the center of gravity of mowers. That is something to take a look at if you're more interested in that particular aspect of design. The other thing is reliability, right? So when a machine is down, it means you're incurring lost revenue. It's wasteful, and so our machines have to be highly reliable on the job every day. It's what makes your paycheck. So reliability is a huge focus. The other thing is that we just have a passion for optimization of cost and performance, right? So we want to make really high performing mowers, but the more we put in the mower, the more expensive they get. And so we're dialing those knobs very carefully and studying all the issues and specifically making design choices that create this optimization. For example, I'm going to show you this chart here. So a mower that might last 4,000 hours, which might be between two owners or something like that. Let's say that mower cuts 20,000 acres and there's a direct cost of about 116 grand to do that. And that cost is made up of a number of different things, right? There's machine costs, there's the things that contribute to availability, there's the labor components. Well, if you follow the numbers here, 116K, about 46 to 70K is the split here, right? So the labor is really the big number, okay? And the biggest factor on labor is the machine's performance, acres per hour. The performance of the machine is made up of two things. In larger flat areas, it's about cut speed, which has a lot to do with the design of the deck and a huge amount to do with the engine's power. In more compact areas, it has a lot to do with maneuvering, which has a lot to do with stand-on mowers and center gravity and be able to get on and off the machine quickly and these types of issues. So we really focus a whole lot on this branch. Now over on this branch, when we get into the components of the machine, there's some important things that we're looking at here, right? So the machine cost less the residual. We do a number of things to try our best to make these machines still valuable when you're done with the machine, right? So maybe you might run the mower for 2,000 hours and you want to sell it in the used marketplace, or you want to trade it in or something like that. Everything that we can do to make that machine more valuable at the end of its life means that can come off the purchase price of the machine in terms of the life cycle cost. On the fuel side, that's another big number, and the biggest thing we can do there is use a EFI engine instead of a carbureted engine, which makes about a $500 difference. There's some things that we can do. Actually, when you buy a mower, it's $800 or so gets eaten up in financing pretty quickly. So there's some things that we can do on our end of how the business is managed to try to reduce the amount of money going to interest in banks to finance things like inventory, the retail finance side of it. We get into maintenance, right? So the ZXT, we've got another video about the ZXT and all the math that goes into the maintenance cycle on the ZXT. Why it is that we have the oil guard system, why it is that we have the 1,000-hour oil change interval on the hydros with the 8 quarts. Some of those things in here. Why we don't have grease fittings. We have very specific reasons for doing that. And it's to, one, it makes the machines more reliable, but the other is it has to come out of service less often. And when you look at the number of grease events in the life of a machine, it actually becomes a pretty big number, somewhere around $600. So in theory, our budget to make a mower grease fitting free would be about $600. The reality is it doesn't cost us quite that much to do that, and the difference there is the value that you're getting, right? So if we can spend $50 or $100 to make the machine higher quality, not require as many grease fittings by using things like sealed ball bearings in more places. If it costs us $100 and saves you $600, you're getting $500 of value over 4,000 hours on that. So we look at a lot of these issues in depth, in real deep, to maximize this optimization and value that you receive in the machine. The other thing is that I believe that the control, the feel, the balance of the machine is extremely important. When you spend a lot of time with a machine, it becomes like you're part of your arm. It becomes an extension of your body. Really, really good coordination of it. One example that I talk about is if you've got fence posts and you're going to mow down the fence line, right? You want to kind of go between the fence posts, dodge in, and you want to get as close as you can so the trimming goes fast and easy, right? To do that quickly with accuracy, you need very, very precise and responsive controls in the mower. So the control feel, the weight, where the weight of the mower is and how that affects, when you make a turn. But just a really good tight control of the machine is so, so important because it's essential that in order for you to love our equipment, we have to also love it. I think this somewhat comes from something Elon Musk said about how, if you don't love your own products yourself, how do you expect your customers to love them? And so we make machines that we really like the way they feel and handle, and that's a priority to us. The serviceability, repairability aspect of our machines, we know that all of our machines are going to break down, especially over a couple thousand hours. They're going to break down. They're going to need fixing. And we're technicians ourselves, and we respect the struggle that those who fix our machines go through to make them work again, right? So all of our engineers, we build our own prototypes. We're running the test programs, we're replacing the parts, all those kinds of things. And so, like I said, we're technicians ourselves, and we respect what it takes to maintain this equipment throughout its life. So longevity is a little bit different than reliability, right? Reliability is about being on the job every day. Longevity is about a machine that lasts for a long time. And a machine that lasts longer, you get more value from, right? So, you look at buying machine A and machine B, and there's a 10% difference between them, and you really want to buy the cheaper mower. But what if the mower that costs 10% more can last 30% longer? There's way, way better value in that. So by making our machines last a long time, it allows you to have a lower life cycle cost. Some of the things we might do there, like I said, we might use ball bearing pivots. We might use large chrome rod end joints. We have very, very little metal on metal pivots that are welded together, and you can't service the pivot. Those are all things that create a terminal lifespan of the mower, and the more we can do to create longevity here, the better value you get from your machine. Damage resistance. So we know these mowers are going to probably hit stuff. They're going to be jammed against each other in a trailer. They're going to get snagged on things, right? And in a fleet operation, you have someone running the machine who doesn't necessarily own the machine, and so it's going to get run really, really hard. So we build it expecting that these machines are going to get hard use in non-ideal conditions, and just sort of battle-proof, we might say, our equipment. Our new ZXT product, that machine more than ever really has a lot of these kinds of features in it, in its design. The other principle here is that a lazy design is complicated, but good design is simple, right? So you can design something and achieve the functionality, and we don't stop there. Sometimes 90% of the work is actually making that function less complex, simple, easier to maintain, make it so that it's more repairable, it's more manufacturable. So just creating the function is the easy part, but we don't want to be lazy. We want to work really, really hard to perfect those designs and reduce the part count, reduce the amount of things that could wear and break and whatnot. And so that's where a huge amount of the effort goes on designing equipment. The other thing is that form follows function. In other words, aesthetics should never compromise function. First and foremost, we're building a tool that is highly productive, highly reliable. It is compact. It's all these things, these functional things. That comes first and foremost. We do pay attention to aesthetics, and they're important to some level, and it's just almost an expression of our craftsmanship that we get the aesthetics to look right. But we never start with the aesthetics and let it compromise the design, or have the aesthetics compromise the serviceability or these kinds of things. The function always comes before aesthetics. So hopefully this is helpful to you to understand a little bit of some of the things that we think through when we design our equipment and our accessories, and the detail that we put into all this.